All right, dropping ball. So we're gonna use animation to drop a ball from the top of the panel down to its bottom. And then I'll modify that in a few minutes to do a bouncing ball. So it'll drop down, bounce back up, drop down, bounce back up, back down, and up. First, we'll just animate it to drop down. Okay, so we'll go over to Eclipse, make a new, we're in chapter 3G, new class, dropping ball. Put in our comments at the top. Block commenting, my name or your name. Date. Maybe a brief description. This program will drop, we'll use animation to drop a ball. All right, and then we need an import. Java.awt for the graphics, everything. For this code, I think let's see, I'll do everything in main. I'm not sure yet. I'll decide in a minute. So we'll start off by setting up a drawing panel. Drawing panel, let's call it P equals new drawing panel. Graphics object. Oh, we need to set up the dimensions on that too. So graphics G equals P.getGraphics. Let's make our window, let's make it 800 by 400. Just run that, see what that looks like. Oh, I meant to go the other way. I want it to be 400 by 800. I might be too tall. Let's see what happens. That's a little too tall. So let's go 400 by 600. Perfect. So that fits on my screen. If for some reason it doesn't fit on your screen, you could make it a little shorter. Trying to decide if I want to use methods here or just drop the ball. Let's just drop the ball and then maybe I can put it in a method after. So we'll do g.fill oval. And let's see, so I got to figure out where it is. So let's jump over to paper for a second. And if I have my window here, any kind of figuring out of stuff is easier to do on paper of where something's going to go. So I want the initial ball to be up here, centered in this window, and I want the ball to be sort of, maybe let's make it, let's see, we're 400 wide. Let's make the ball 50 by 50. See what that looks like. So we're going to go 50 across and 50 down. And then we want that to be centered in the window that is 400 across. So the middle of this would be 200. And then we need to go to the left of that to get to this point. Just trying to see how I can write this in here. If that's 200, then this little distance here is 25. So that point has x coordinate 175 and y coordinate 0. Okay, and then again the rectangle that it's enclosed within is 50 by 50. So much better to do that on paper. because otherwise you're just going to be sort of trial and error. And what happens is when I want to go use a method to do this, maybe drop the ball or something, it's much harder if I'm doing it without having figured out first what the dimensions are that we're dealing with. So 175, 0, 50, and 50. And we should be able to run that. And oh, that did it, but it didn't make it red. So we want to, prior to that, say g dot set color, color dot red. I don't know why I did this on that same line. Makes it hard to see. And run that again. Again, notice how I run like, I don't want to try to do a whole bunch of code and then run, because then it's very hard to correct errors. If you have an error right now, there's only 4 lines of code. You should be able to find the error. Okay, so then what we want to do is we want to have that ball incrementally move down the page. So I'm going to come back here for a second. And this is pretty small what I'm trying to work with here. So let's just get a new screen. No, that'll work. Okay, a new screen here. So here's my window. Never hurts to redraw stuff. Here's the ball we just drew, except we want it to be red. Just cheat color around it, and it's solid. Okay, so I want it to fall, drop down here, and land down here. So we want to figure out what that point is. That point is at 175, so same in the x direction, and then the window is, I think, let's see, 400 by 600. This is 50 by 50. So that y value there is 50 up from 600, or 550. So y, let's do I maybe, and a y here. When I is 0, oh, we don't know I yet. Well, that's okay. When I is 0, y is 0. And then when we're done, we want it to be 550. So we want to figure out how many times we want to move the ball. So it doesn't really matter. We could try moving it by tens. So when I is 1, we would want this to be 10. And then 2 would be 20. And then it would be down here at 55. So that tells us how many times we want to run the loop. 55 times. And each time we go through the loop, the y value is changing by 10. So the change in y, or the dy, equals 10. Okay. And notice where that work is happening. That logic is all happening on paper. It's much easier to figure out on paper what you're doing. Notice how I created the I value at 0. I figured out the y values, and then I went back and filled in what the I values should be. And I made it up. I decided to go by tens. I could have easily gone by 5s, 20s, 50s. 20s would have been more complicated because that's not a multiple of 20. Okay. So this will happen within the loop. We'll say for integer I equals 0, I less than or equal to 55, and then I plus plus. So I is going to increase by 1, but then y will increase by 10. So we'll take this same code, paste it in here, and then the y value here is going to be, so remember, come back over here, y, it's a linear relationship. It's m times I plus the start value. So the m is 10 and the start value is 0. So we don't need variables for that because we can just put that formula into this coordinate here for y. 10 times I plus 0, so nothing there. Okay, and what this would do if I don't clear the panel, this will just move the red ball down the page. That's kind of cool looking. We could slow that down by doing a panel dot sleep, so you can see it happening. Let's go by 100. I'll run that. It's pretty cool looking. So that's how you could draw a line. That's drawing. That's one way we could use animation. In this problem, I want it to move the ball down the page as opposed to drawing a line. So that means at each phase, I want to clear the panel out. So I want to do P dot after the sleep. Yeah. So it depends on whether you want the ball to stay at the end or not. Let's put it down here for a second. P dot clear. That'll clear the screen away after each loop. The problem with this, if you watch the ball dropping, so there's this weird flashing thing that you see. That comes from a couple of things. Let me just show it to you again. You know, imagine this type of animation on paper. You would draw a bunch of different scenes with the ball moving, and then you would flick them, and then it would have a flicker effect when you did that. There's a couple of things we could try to fix it. We could make how far it drops down each time a little less. We could speed it up. Those would improve it, but it's always going to have a flicker. So I wouldn't worry about that. I don't really want the ball to disappear at the bottom. So the reason it's disappearing is because I'm clearing last. Instead, I could clear first, and then that would leave the last ball there as it drops down and reaches the bottom. There it is. So, you know, I could actually, let's see what happens if we speed this up a little bit, see if that flicker improves. It actually got worse. So what if we slow it down? I think if we wanted to improve that flicker, we might have to go by 5s instead of by 10s. It's a little better slower because it's still flickering. The reason that's flickering is drawing and undrawing. So you're seeing it, and that's causing it to look like it's flashing. But that's what we're gonna have in the animation. We're dealing with very rudimentary, very elementary skills here. Like we have a few shapes and then a few things that we can do with them. So we're done with this code, but imagine now that we want to drop this ball in some scene, okay? So if we had a background here, the background would have to clear out every time. But what we could do is we could have a method sort of right here that says, you know, draw scene. And maybe, you know, what would the parameters for that scene be? Well, you would at least need the graphics object G. And then you might also need the panel. It depends on what you're doing. For example, you probably don't need the panel if it's just drawing. You do need the panel if you're putting a sleep method in, because there's the panel.sleep. But notice the drawing of stuff are methods of the graphics object. It's only clear and sleep that are methods of the dropping of the ball. So then down here below main, I would have another function, public static void draw scene, and it would have a graphics object G. Let's call it graph. And then I'd have that scene. We have an error. Public static void. Not sure what this error is. Public static void draw scene. Oh, I see. Maybe, no. Am I inside of main? Yep, I'm inside of main. So this function cannot be inside of main. See, that happens when you have bad spacing. So there's the end of main. And there I can put that outside of main. So that was a weird thing because it was telling me I couldn't have a void on that, which clearly I can. It is type void. The problem was not really with the void. The problem was that my function was still inside of main because I had this other one here. Okay, so that's an empty function. I'll just say, it's an empty function where we could draw a background. So this is how I could animate a scene. So, I mean, obviously the dropping of the ball is sort of a rudimentary animation, but you could have a scene around it and you could imagine that ball being anything, right? It could be a hot air balloon and it's coming down, or it could be the sun coming down and it could come at an arc or whatever. And each time you went through the loop, you would clear the scene and then draw the scene and then do whatever animation you're doing and then keep looping through, and that would do the animation. In this scene, there is no background scene. We just have the ball dropping, and down it goes. So now I slowed it down too much. See how slow that is? Like, waiting for an eternity. So I'll fix that, speed it back up to 100. And why not just play around with this a little bit? Let's just do graph dot draw rectangle. Let's put it in at, let's put it on the bottom. So let's make it at 0 in the X direction. Let's go down to 400 in the Y direction. Our window is 600, so then it's going to be a width of 400 and a height of 200. And this should be a rectangle in the bottom of the scene that's green. Nope, it's going to be red. So let's make it a color. Graph.setColor. We can make it any color we want. Let's go with brown. So now I didn't like that. Sure, let's go dark gray. And that's going to have, where's our rectangle? Where's our, oh, I never called the function. So I wrote the function, but I still have it commented out. So it never drew that rectangle. But now, and maybe this is more than just a rectangle. Maybe that's the ground and we have a tree, and errors exist. Okay, let's see what they are. There's the semicolon. So I've just drawn a gray rectangle here, although it doesn't look like it's the right color. Why not? Let's try black and see what happens. Oh, because we're drawing a rectangle. We're not filling the rectangle. So there was no error, just a misunderstanding. I'm trying to do this. Now it'll be black, and then there goes the red circle into the black rectangle. Yay, okay, there's the dropping ball. And then, of course, inside this draw scene, we could have anything in there. We could have trees and whatever, hills, whatever. All right, that's dropping ball.